This is a Radio City Products model 444. It's really just a multimeter. You can see that that meter is loose. It's sort of just hanging in the breeze in there. This particular multimeter is kind of strange. There's no selector at all on it. That one knob that's on there is for zeroing out the meter. And typically there's a knob over here that allows you to select ohms or AC voltage or whatever, but this one doesn't have anything. There is these two leads here. I'm not familiar with that, but it could be that acts as the switch, and that's how you go about selecting what you're going to do with this multimeter, what you want to try to measure. Yeah, you look at the inside of this thing, it looks like it's kind of been through a lot. The meter, like you see there, is loose right now. I'm going to try to get it mounted back inside there, and for some reason this is sliced all the way around. There's a couple of leads here that I noticed right off the bat. They're just kind of hanging in the breeze, both of these green ones that have the coils on them. I'm guessing that those two leads go to the battery. Like I say, there's no schematic, so kind of have to take a guess what the voltage level might be. I'm guessing maybe 4.5 volts, something like that. That's probably a rectifier right there. That thing right on top of the meter so that you can feed it AC voltage. I don't think there's any schematic, so what I'm probably going to do is go get an old schematic from a meter about the same time, probably one that used a battery as well, and take that drawing and try to familiarize myself with how these meters work, because the truth is I really don't know how anything works until I start working on it. So yeah, I thought I'd show you this. Well, I took the meter out, and the meter itself, you can see it's kind of bent there. The needle, if I move it, it's got some deflection in it. I don't know if that means that it still works, and I don't know how sturdy a meter is, to be honest. I've never really worked on them very much, but I think that collar needs to be straightened out a little bit. Anyway, so this crazy looking menagerie that you see here is what I had to do in order to get the meter back in there, put it back together. Honestly, I thought it was going to take 15 minutes, but I spent 4 hours playing with this thing. The real trick came in trying to line up that little mechanical screw that's on the lens on the glass. You see it right there. That's to give you the ability to tune this thing a little bit mechanically. I had a hard time getting that thing to line up right, and obviously I don't even know if the meter's bad. I mean, there must be some reason why they tore it apart, right? So I may very well find out that the meter is bad. You can see when I move it, it bounces around a little bit there. Anyway, I did manage to get it back together, but it is a real kludge to get it to hold in there. And what I want to do is just put together an as-built drawing. You know, I don't know if it's right or if it's wrong, but I'm just going to say this is what I'm starting out with, and this is what I've got. But basically I'm going to lay out the drawing just as it looks right here, because it's pretty simple. There's only a few components, and if we look along the left side, you can see that there's a lineup that goes across these ports on the side, and it's like a ladder run of resistors, and the lead that we see coming out of here goes to that rectifier. So that's obviously the AC side On the opposite side, we have exactly the same thing, but it doesn't go through the rectifier. This looks like it's probably for DC power. On the bottom are all of the high, medium, and low ohm jacks. It's also for amperage, and I haven't figured out how that works. Over here is the COM port. You can see it right there. I think that just about covers it, but what I'm going to do is just make the drawing look just like the back of this device. The only source of DC power on my bench that will cover all of the ranges in this meter is my Olson capacitor analyzer, the closest thing to a Swiss Army knife I have. I'll use it to spot check each of the DC ranges at the power level it uses for progressive leakage testing. Note that I haven't done a restoration of the Olson, and the voltage levels may be imprecise. In this clip, I'm showing 3 tests I ran for the RCP 444. The leftmost readings are of the Olson voltage levels taken by a digital meter. In the center, similar readings are taken with the analog meter, the 444. On the right, we have a set of readings taken with both meters in parallel. The clips are edited and synchronized so we can compare the results. Even without going into a lot of detail, a few things stand out in this testing. First, there is a noticeable voltage drop in the DC meters between solo and parallel testing, yet the analog meter appears unfazed. This is likely the result of uncertainty, where the vintage analog meter consumes too much of the device under test power for its own needs, too much to be able to render accurate results, that is. Secondly, in each of the ranges, we see the accuracy of the meter is nonlinear. As the needle approached the far right side of the meter, beyond 75 or 80%, the accuracy drops off precipitously. Given that it's across each range, I'm guessing that it's a mechanical issue with the meter itself, perhaps a spring or anything else that might affect the tension. Here I'm going backwards through the 1000 volt range to make sure I hit every voltage level on it. An interesting sidebar, I note that the Olson is around 8% over voltage. I've measured it with 2 digital meters and turned up the same results. Yet in the 80% space where the analog meter is running fairly linear, its measurements are in strong agreement with the Olson's labeling. I don't know if that's a coincidence or if the Olson was designed with analog meters and that's why, but I suspect the former. Here I'm retesting every voltage level on the 500 volt range. I wanted to do a little bit of testing on the AC side over here now, which are these jacks on this side. And I've got I'm running the WaveTech and in waves. It would be great if I had a decent power unit. I'll probably have to look around and pick one up, but so I'm generating I don't know what frequency I'm at, it doesn't really matter, but it's an AC signal, 10 volts. That's too high from where I want to start testing. So I'll turn this down. I'm at 1 volt now, so what I want to do is test on this 5 volt jack first and then work my way up. Okay, so we're plugged into the AC and we're registering 7/10 of a volt. So it's under, but let me see if I can go any higher with it. I don't want to go to the next one. I should turn this down probably and see how high this goes. Well, there's a max right there. That's what this thing records is 5 volts. So that comes out to be 6 volts. I guess, what does that mean? It means there's too much resistance on this old one. I'm going to move this probe up to the next one, see what kind of a reading I get there. Let me move this up. Yeah. Yeah, we're getting a reading. That's the maximum. 5 volts. I don't think that's what that is, but let me check. Let me move it back over to the digital meter. Yeah, this is reading 10.8 volts. It was dropping half the measurement. Okay. I just finished replacing one of the resistors, and I've kind of got this thing set up to what I think would be close to the midpoint. So this should come about to the middle of the meter, and it does. Still, I'm low on the voltage there. I didn't replace the resistor between here and the meter though, or actually between here and the rectifier. I probably could replace that, so I shouldn't expect too many changes there. I guess if I max this out again, that it'll still read 6 volts, and it does. Okay, I'm gonna move, I've got it hooked back up here. I'm gonna move it up to the 50, and I guess 6.5 volts maybe there, it looks like. Maybe a little less than that. 6 volts, 6.5 maybe, which is what it was reading down here. Let me turn this up as high as it'll go. And right now I'm reading, I think it's reading about 12 volts on here, and I think that really it's 11. So I would say that this is reading on the high side too. Well, I bent the needle playing around with this. It slammed something really hard and caused it to bend, which means I'm going to have to go in there and tear that whole meter apart again in order just to straighten that out a little bit. The ohm thing is pretty complicated, and it doesn't seem to be working right. What I'm finding is that you need to plug these things in order to zero out the meter. And if I understand it correctly, you're supposed to set it to the max. The state of confusion at the time that clip was being recorded is fairly obvious. At that time, I was working off the graphic on the front of the meter, which I didn't feel was very intuitive. I was really only able to get the HO readings to work, and that was just by stumbling into it. The bent needle came about as a result of the experimentation it took just to get that far. It was about this time that I stumbled across the document on the left on eBay, which is for the RCP 408, not the 444. The image on the right is the RCP 442, and it's more or less how I imagine that the 408 might have appeared, with a few minor exceptions. For instance, the drawing shows that the 408 was not equipped with a function selector. Instead, just like the 444, it had only a pot to zero the meter there. Note also that the 408 would have had flex leads as well. Finally, it stands to reason that if the 408 also came equipped with flex leads, they must also have had a more comprehensive set of instructions on how to use them. On page 2 of the short document, we do find a set of instructions that are very close to what is needed on the 444. Amperage reading instructions are not applicable to the 444, but the voltage readings are good, And the process for the flex leads is applicable even if the math they use isn't. As for the 408, it looks like it was available as a kit and required an add-on purchase to handle AC voltage readings, but it did have a more robust set of options for reading amperage. I took pictures of all 3 pages of the document, and the 3rd page appears to provide instructions on how to use the AC add-on device. Okay, I've made a little bit of progress trying to figure out how to make this work by another document that I found. But basically what it comes out to is you have to plug everything in according to the way it says, but do not plug into that jack first. If you do that, then that thing is going to rattle so hard against the right side, it'll shake your house. Well, maybe not, but it feels like it. What you got to do is plug it into this milliamp one first, and then plug it into here. And you see how that pegged the needle? That's because I've already said it. What you do is you just turn this, and it's really, really touchy. I think this thing is probably needs some cleaning, but it looked to me like it was sealed. That's about as good as I'm going to get it set up. Once you do that, you can leave those probes in, and then you can do a low measurement. Once you get the low measurement in, and I've got a looks like a 47 ohm resistor. If it wasn't for the fact that that needle was bent, we would be pretty close. It's in the 40s, at maybe 50. You got to read that low ohm reading on there, by the way. The one in red close to the middle. Once you're, only when you're reading off of this port. So yeah, it's about 47. That's not bad. I have one other resistor that's within its range, but it's pretty close to the top of the range. You can see that the needle has moved over. And again, it's that red one that we're looking at. You can't see it, but the 100 is right underneath where the bottom of that needle is. So it's reading it fairly accurate. Okay, for the next one, I think all you need to do is read from the top one, because the settings are basically the same. Reading the same way, except you pull out, and by the way, the setting is the same over here. And it looks like it's drifted a little bit, but we'll ignore any deviations here. And then you plug this into the vacant MO slot, and this is where you start reading from the top, that top line up there. And if that was a little bit straighter, it wouldn't be pointing where it is. It'd be pointing a lot closer to 100 ohms. I'll set up another one. This one is set up with that 47 ohm resistor, and you see it's pointing almost straight up to 50. So that actually works, except we're reading the same exact range that we were before. I'm going to set it up for HO. That one sets up a little bit differently. Interestingly, it still sets up about the same, and that's probably because of some of the issues that we'll talk about a little bit later, but I don't know if I can tighten up that meter. That's pretty much to the max. But you look, when you set this one up, instead of plugging into 1MA and MO, you just plug into HO. That's it. And you set up the meter. Let me see if I can get it to rattle a little bit. Actually, that is max. So let me let me go ahead and tie into, actually I think I'm set to go. I'm going to pull this out now, and remember I had that 33, what was that, 3.3K? And when I plug this in to HO now, it's still, again, the needle's bent. Sorry about that, but on the top meter, that's getting close to where the 3.3 is at. I was still convinced that there was some sort of order of magnitude discrepancy in the ohm measurements and felt that there was likely one or more missing resistors in my 444. These suspicions were magnified when I started looking closer at the differences between the 408 and my 444 as bought. If we look at the run from the high output jack to the pot, we see only one resistor between HO and MO. Although the locations of the battery and the pot are reversed in the 408, we can see that there are resistors trailing both the HO and the MO jacks. But a big source of confusion for me was that I could close out the 1MA jack and the MO jack with the flex comm leads and still take valid readings from the low jack. How is the meter not shorted out in that situation? Note that the microamp jack in the 408 had a resistor, but the 1MA, which was the closest analog in the 444, did not have one. One thing I noticed was that there was a flying J-hook splice on a lead that ran from the leg of the pot and the place to where it was tied down, the LO jack, before running on up to the meter. I wondered if perhaps there was once a resistor at that splice location. Since the two leads were different colors, I decided it would be a low-risk experiment to break that splice apart and temporarily strap in a low-ohm resistor to see what effect that might have. Just a bit of a heads up. When I went in there and tore that little splice apart there, what I found out is that the wire going to the right, that brown with a black dot on it, is not an ordinary lead. It's actually a wire wound conductor around a center core. I don't know what the center core is, but it's a wound conductor, and it has a resistance of about 19.2 ohms. And I went and figured, okay, well, I've got 2 or 3 other leads like that I probably should check. And I found another of the leads going from the low port up to the meter. That's also a wire wound conductor, and it's 11.6 ohms. And then there's one coming from the MA, 1MA and 10AM MA port, microamp, I guess you would call it. Third conductor, and that one is, what did I measure that one out to be? 1.2 ohms. So it looks to me like those are built-in resistors, very, very low resistance, but very specialized wires. So I think I put a halt on what I was starting to do there. Updating the drawing, I'll separate the 4 leads into individual paths to better illustrate the resistance each lead encounters on its way to the meter. For instance, we can now see that the leg from the pot accumulates an additional 30 ohms when the combined resistance from the wound conductors are taken into account. This answers some of the questions that were vexing me about this panel earlier on. Finally, I'll slide the schematic over to make room for notes to document processes, caveats, and some of the swags that went into making this as-bought drawing. The date is just a guess. It could be anywhere from the mid-30s to the mid-40s, I suppose. After considering the fact that leads that I looked at before to the positive side of this meter, after coming to the realization that those are fixed length, carefully engineered wound conductors designed to create very low resistance, I imagine that that was a design consideration. So I'm going back and taking another look at this meter again, ignoring the bent needle for now. Yeah, we read about 100 ohms on the red meter down there, and that was correct when we used that low jack over there. Then when we moved to the middle output jack, or middle ohm jack, whatever it's supposed to mean, when it read 100, that was actually 100 ohms. That's on the top meter, the black one up on top. But there's a little bit of real estate remaining to the left because that meter reads right to left. And technically, if you look at that, it'll go up to 300 ohms, 500 ohms. It'll go up to 1,000. And the top of that meter reads 5M. I mean, it's what they show down here, 5M. So technically speaking, the meter probably does go up to 5 kilo ohms. The same thing is true with the HO, by the way. When we measured it, we found that, okay, well, 3300K wound up being just to the left of the 30 that you see on there. But if you follow that on up, and take it to the same logical conclusion, you'll get up to 500K eventually, because that scale is logarithmic. And so technically speaking, when it comes to ohms, this thing probably meets its requirements as I bought it. So that works out okay. Now the issue with the ammeter, it says that there's a 1 to 10 on the one on the right, and then through the low jack you're supposed to be able to read 100 milliamps. Okay, and for the life of me, I can't figure out how that's supposed to work. I mean, in all cases, whether I was plugged into the back of the meter itself, or whether I was plugged into either one of those two jacks, I was reading this thing as a 1 milliamp meter when I fed it power and resistor and got in the middle of the circuit. So I'm trying to work both meters into the shot as best I can here. Right now I've got both meters tied in series with the load, and I'm reading just the baseline 1 milliamp scale, and I'm reading 1/10 of a milliamp. And you can see that it's reading that on both scales. Now if I move this up, that is approximately 2/10 of a milliamp there. We're at 3/10 at this point, 4/10, 5, 6/10, and that's hard to get to, but it's about 7. There's 8, 9, and that's 1 milliamp right there. Now, when you look at this meter, I'll pull the probe out for a second. What you see is that it says on this port right here that it'll read both 1 milliamp and 10 milliamps. And I didn't think that this worked. I had commented on it earlier that it didn't appear to support any of it, but that's before I understood that these are COM port cables, and they're used to shunt the meter with different resistance values, and I'll plug it into here, and you can see that it's dropped. Try to put my meter back here so that it doesn't have any glare. Yeah, so now we're at a different scale. We're still reading 1 milliamp, but we're at 1/10 of the total scale now, so we are reading at a 10 milliamp scale, and I can move up through there again. There's 2 milliamps, 3 milliamps, 4 milliamps, 5, and that looks like 6, 7. Now between 6 and 7, we're beginning to see a little bit of drift there. Let me go back to 6. This is 6 milliamps. Then when I move to the middle of this scale, it's 7. But it's only reading 6.77 over there. So we do get a little bit of drift starting in that area. 8 milliamps. 9 milliamps. And there's 10 milliamps. And it's reading 9.74, so we would have to go over a little bit. I think that's, yeah, I pretty much have that at the right spot. 9.7. Okay, so if you look, let me open up this circuit one more time. And remember, we're at full scale right now, reading 10 milliamps. If you look at this port right here, this one right there, it says that, you know, it's the low output jack, but it also says on the bottom that it supports 100 milliamps. So I'm going to move the probe over there into that slot. And instead of shunting on that other side, I'm going to shunt this side over here. Now, if you remember when we looked at the circuit drawing, this was like 1.2 ohms right there, and the other one, the one that's tied up to the low output jack, is about 11.6. So, and I was just measuring those in circuit, but I think what they're doing there is that there's one order of magnitude different, and that's is what we're trying to do with a 10 to 100 milliamp scale. We want to move that scale up one order of magnitude. So I'm going to put both of these meters back in circuit. Oops. Hope nobody got jostled too bad with that. Just hit the tripod. And you can see that rather than reading full scale on the analog meter, we're now back down to 1/10. So yeah, at 10, in fact, let me line it up. There's right about 10 milliamps right there. And that lines up pretty good on that scale. My WaveTech doesn't push too many more volts, so I can't go up too much higher. I'll try to push it up as far as it'll go. And that's about it. You see on the digital meter that reads about 14 milliamps. And if we're looking at the analog meter, that's 2 milliamps per division now at the 100 scale. So we bumped it up almost 2, not quite 2. So it's not 14 milliamps, it's just below that a little bit. So there's a little bit of a difference between what the analog meter reads, but by and large, I originally did not think that that this thing had all of the capabilities that it shows on the labels on the device. I mean, working without any documentation, I wasn't sure how to do this, but now that I go through the motions, I can see that that it does satisfy most of their specs, um, to different degrees. Yeah, the ohm meter, it handled all of the scales that it said that it would, but it only really, practically speaking, is only good up to about, I would say, 50K. You know, beyond that, the uh, the meter takes off too hyperbolically to really be able to be of any use to do any type of accurate readings. So, um, you know, before I started messing with those leads and for the ohm meter, and before I went in and realized that those leads are actually custom wound conductors that are have particular resistant values. Before I realized that, I didn't quite understand how this meter was designed, but I see what they're doing now, and you know, it's better than I thought it was. Do I think that this thing's gonna would be a usable meter? I don't think so. I think that, you know, with all that business about plugging those flex leads into different jacks and then zero adjusting the meter and all of that kind of stuff, yeah, it makes it a little bit cumbersome. As far as a multimeter going into reading ohms and amps, I don't think so. The reason I bought it is I like the looks of this meter. I think it's just a cool looking design. Radio City Products did a good job when it came, at least in the early days, of designing just a cool looking meter. I would say that, you know, some people speculate that it's in the 50s. My thinking is that it's mid to late 30s. Just looking at the resistors that it had in it and just the design itself. I mean, this is super Art Deco or Machine Age. I'm not sure what you would call it, but it just has that look. I'm going to update the drawings and show some of the caveats and some of the stuff I built or I found. And I'm going to label the drawing as an as-bought drawing, not an as-built, but as-bought. Thank you for watching.